creative college represents the principle of sustainability. The site is located in Bristol, southwest of UK, with an area of 100,000 square meters. The precipitation weather is mainly partly cloudy and overcast, scarcely sunny. It has a strong west-south wind, and its annual rainfall potential is high.
The primary and secondary school are respectively located on the west and east of the site, with south-facing facade optimizing the daylight. Outdoor corridors play a role as joint between two teaching buildings, promoting neighborhood creativity. The shared school, including canteen, sports hall, library, lecture theater, and auditorium, is designed in the center as connection between two schools. The central axis circulation with horizontal circulation, encouraging pedestrian activity and access to all required functions. For visual comfort, buildings are surrounded with landscape and playground. Considering the possibility of increasing population, there are areas reserved on the northwest and northeast of the site for future expansion. The educational objective of this design is to facilitate students' innovation and teach them the significance of sustainability and equality. To improve learning efficiency, students have easy access to outdoor courtyards and sufficient daylight. Renewable technology and sustainable materials are exhibited around the campus. Accessibility facilities for disabled students are provided in parking lots, toilets, and lifts.
Three main environmental objectives: reducing heat gains, reducing energy consumption, and utilizing renewable resources. Building energy consumption can be reduced by applying well-insulated fabric and daylight and natural ventilation. Prefabricated straw bale panels have a great environmental impact compared with steel and concrete, reducing carbon emissions. This project would choose products from Mozilla Company, which achieves the certification of Passive House for the life cycle assessment. It avoids unnecessary on-site waste, and the transporting distance is reduced due to a flying factory in Bristol and a local store.
In terms of daylighting, efficient daylight could reduce energy demands on lighting. However, unnecessary glare is harmful. In order to avoid glare, computer-controlled blinds in classrooms track the sun and catch and diffuse light throughout the day. The blinds automatically tilt according to the sun's position and are programmed to close at night to reduce light pollution and help maintain the building's temperature. To improve light distribution in corridors, high-gloss, reflection-coated material vertical blinds were installed to form a light wall that maximizes daylight distribution.
The ventilation system includes natural ventilation and heat recovery ventilation. The clerestory on the north side of the roof draws heated air away from the floor plates to the roof, where it leaves the building. This stack effect provides natural air movement throughout the building, thereby reducing fan energy. The classrooms apply heat recovery system for HVAC system. By recovering residential heat in exhaust air, the fresh air into the building is preheated, and fresh air enthalpy is increased before it enters the room. Heat recovery system typically recover about 60 to 95% of the exhaust air and can significantly improving the energy efficiency of buildings.
At the end of the central axis boulevard, a garden roof links the teaching building, theater, and the auditorium. It plants an insulated roof membrane assembly green roof, which provides additional waterproofing protection. It spreads plantings across approximately 50% of the roof. Reflective surfaces are used on the remainder to reduce heat absorption and cool the air. In addition, gardens could offer students. In terms of renewable technologies, ground source heat pump, PV panels, and rainwater collection are used in this design. PV panels are placed on roofs, transferring solar energy into electricity. The orientation of installation is facing south. In order to maximize the efficiency of operation, they are mounted at a certain angle according to its latitude and season. The electricity they produce is used for electrical appliances in this college and the ground source heat pump. Considering integrated energy system design, permeable paving is installed on the sloping side walls that allows rainwater to be collected and reused, for example, for the flushing of toilets. Fabric is designed to be inclined to help rainwater flow. The paving is underlaid by an impermeable tank that traps the rainwater. The innovative step with the GSSP is that the coil is installed under the permeable paving so that the ground loop sits in the collected water. This allows efficient heat transfer from the ground to the ground loop. The GSHP then supplies all the space, heating, and hot water for the building. When PV panels and the ground source heat pump work together, which achieves a reduction of approximately 50% carbon dioxide emissions.